I'm Tomasz Tarczyński. I work at Gigaset as system architect, and I want to talk today about configuration management as a topic and how does it relate to Kubernetes, what techniques could we use in this area. Topics for today, what GitOps is in general, and then the tools that I would like to show you. So one of them is Flux and the other is Helm. And I will try to give you a short demo of it if time allows. But first, to give you some background, like what configuration management means to me, what I understand there. So for me, it's all about infrastructure as code. So that means to codify everything that happens in your infrastructure, all configuration of your system, all stuff like that. And it also means to me that I would like to always use version control system like Git to keep all information about the state of my systems. And there are some, let's say, traditional tools that are used in that space, things like Puppet, Chef, Ansible. So a question to you, how many of you have used any of those tools, like Ansible or so? Okay, so you are already familiar with those concepts. Personally, I've worked quite a lot with Puppet, and what ideas, constructs I really liked about it were things like the domain-specific language, so DSL, that is a very constrained language just to describe configuration. Another feature, it is declarative, so you only describe the desired state, not the steps needed for the system to go into this state. Then there is templating language specific to Puppet. There are modules. This is also important to me, like I can share my code with either private or public modules. I can even publish them and share with community. And there is in Puppet this code data separation. So the module that describes some configuration is a separate thing, and then the parameters that are specific to my environment is a separate thing. So yeah, that would be it to just introduce the background. And now let's move into Kubernetes. So what does Kubernetes change for me when I go to manage the configuration of my systems? First thing is that with Kubernetes, we've got this control plane that provides us a declarative API. So we already are able to declare the desired state, and we've got this Kubernetes machinery to make the system converge to it. So we would then think that really a quite big part of the configuration topic is already covered by Kubernetes itself. But still, even with Kubernetes, I still would need some small parts to be added to this picture. So, as I have my control plane with declarative API, but I would like to have possibility to declare all of the state in version control system in Git, and then have some automation that would make sure that my cluster state, the configuration in the cluster, would converge to what is defined in version control. And the other thing, would it be possible to have something similar to those Puppet modules? So when I need some piece of technology to have a way to make bigger, more complex description of this and then share it with others within my team or even publicly. So I will today try to show you some ideas how those needs can be covered. Yeah, there is this distinction in the configuration management area. Like you could approach configuration either in a declarative way or imperative. So declarative means only describing the final state that I want, and imperative would mean I write something like a script with a list of commands, each of it is changing the state of the system, and at the end I've got what I want. And from my perspective, the declarative way is way safer for me. Yeah, and now to give you an idea how what would it mean. So when we work in a, let's say, imperative way, it would mean that I, as an operator, or even some kind of, you can think about this, maybe some Jenkins server is here, or an operator himself, we just provide images of our containers, and then we use kubectl to interact with our cluster, and we just, by a list of commands, make the cluster to move it to the state that we won't have. Yeah, so that for me would be still like an imperative way of working with Kubernetes. And then to make this management of configuration and synchronize it with version control, there is a very simple tool meant just for that purpose. It is called Flux. Tool for continuous delivery or even continuous deployment, I would say. So it is a simple daemon running inside your Kubernetes cluster, and it has just a very simple purpose. It synchronizes your Git repository and then apply all the state described in this Git repository onto your cluster. And just very recently, that project joined the Cloud Native Computing Foundation. So it was developed for something like 2 years by a company called Weaveworks, but now it is contributed to the community, to Cloud Native Foundation. What would the use of this tool change for us? So we've got this picture with operator making kubectl apply. And when we introduce Flux, it would look like this. So basically, I still have to provide the Docker images, but I no longer make any kubectl changes like kubectl apply, but rather I put all those YAML files, all those manifests into Git repository, and then inside my cluster, I have this additional component, so the Flux daemon, which synchronizes Git repository and applies this state to the cluster. So yeah, like a very simple concept, but I would say really, really helpful as well. Okay, so now it's time for a short demo. I will try to show you how it works in real life. Yeah, actually it's the first time for me doing live demo like that on the conference, so yeah, bear with me and keep your fingers crossed for everything to work correctly. Okay, to make it not too long, I have shared all the code in GitHub, so you can try these things yourself. I've put there all the steps needed, but some things like installation of Flux are already done to make it a bit faster. So I have a very simple application running in Kubernetes. So it consists of those 4 manifests. So I will create a namespace called demo, then a very simple config map, with just index.html file in it. Then there will be a simple deployment. And as usually in Kubernetes demonstration, it would be just nginx to give you something very, very simple. Okay, and the service, it's also something quite simple. So we expose this deployment. Okay, and normally, without this Flux, I would need to do something like kubectl apply all the files, and that would be it. But as we want to automate configuration management, we will do something different. Okay. So I've got this demo in script, so if you would try to do it yourself, you can just follow those. First thing, inside my cluster, I've got this Flux daemon running, so this is the component responsible for synchronizing the configuration. We would watch in separate console what's running in my cluster. So I'm watching for those objects in the demo namespace. And then we will kick this GitOps, so Flux daemon on. My configuration for this demo is that my Flux daemon in this cluster watches only one folder in the very same Git repository that all the demonstration sits in. So there is the manifest folder here. It's now empty, but I will put those 4 YAMLs into it. Commit those to Git. And next step is when I push those changes to GitHub, I should see then changes happening in my cluster. So I push and immediately also look inside the logs of this Flux daemon. Okay, and now we should wait just a few seconds. In this case, I've configured Flux to synchronize with Git every 15 seconds, so after a short while, something should happen here. So we've got in Flux logs information that the 4 objects declared with those YAML files just got created, and then inside the cluster, we see that those workloads are already running. Okay, now we will have one more example. So when I've already declared what I want in my cluster, now I want to make some changes. So deploy another version, stuff like that. So we will again watch what's happening. So watch the objects, what pods are running, and also making curl just to query the endpoint exposed by the service. So I have currently 3 pods running with version 1.10, and my curl also shows that this is the version of application running. And now I will make a very small, very simple change. So instead of version 1.10, it will be 1.11. again, I commit the changes to Git. And then, like previously, pushing the changes and observing logs to see when changes happen. So it was the previous change when objects got created, and now we wait just a few seconds again to see the actual change of the version happening. Okay, and here we can see that configuration got changed by Flux. And here in the cluster, we see the next step resulting from this. So the changes inside the cluster are going on. So pod by pod got updated. Okay, and one more thing that I would like to show you is how this GitOps approach can help us. So let's say I would by some mistake delete all the workloads from my cluster. So I've got this demonstration application, and I mistakenly delete the whole namespace with everything running in it. So I do this delete, and then we'll also look into logs. So the namespace got deleted right now. We've got those two previous changes in logs. And now when we wait a few seconds, we should see that Flux daemon running in the cluster will again converge the cluster state to what is defined in version control. It would probably take a few more seconds before the namespace is really deleted. Okay, and now we've got information that those objects that were defined are created again. And our application, just in a few seconds, will start to work as before. So we've got our previous state recreated. Okay, and the last step here is that I will delete what was defined here. So when I no longer need my application, I should do then a very simple thing. So just delete the manifests from Git. Okay, so we observe what's happening in the cluster. Then delete those manifests from Git. And by pushing the changes to GitHub, I should again in a few seconds see that the change is happening inside the cluster. Okay, so it should be again something like 10, maybe 15 seconds before it kicks in and starts changing the cluster. Okay, so after deleting those manifests from Git, we've got the objects in Kubernetes also get deleted. Okay, so now let's move back to the presentation. So this was the first part, and I would say the most important idea that I wanted to show you. So this synchronization from Git to the cluster. There are two more concepts, but yes, we've got not so much time left, I believe. So I will try to describe those to you, and we will see if I will manage to give you another part of a demo or not. So we have already declared all the state of the cluster in Git, but now let's imagine I got maybe some dozens of those clusters, so many clusters running. Then in each clusters, let's say I've got again some bigger number of objects that I want there to be running there. So then managing all of those would still be quite chaotic and would require me a lot of effort on my side to put all those YAMLs into my Git repository. So I would really like to have something similar to modules, so to describe some bigger number of those objects into one package, one description. So this is where Helm kicks in. So it's described as a package manager for Kubernetes. It lets you actually put all those manifests together and then share those with others. And I would say it is the de facto standard. Like if you look for any kind of project meant for Kubernetes, really most of them will provide the Helm charts describing the configuration. Maybe another question to you: how many of you worked with Helm? Okay, so most of you already know this, so only a very short introduction. It lets you describe some more complex applications, lets you have in-place upgrades. So, yeah, also manages the life cycle. Lets you sharing to share your charts publicly or also in private repositories, and also provides an easy way to roll back your changes, so to move to the previous known good state of things that are running. Okay, as we are quite short on time, I will skip this Helm demo. And now another idea, so this third part, is how can we join those two ideas together. So I've got my Flux daemon in the cluster, and I've got Helm to package configuration. How can I use those two together? So there is another part of the Flux project, and it's called Flux Helm operator. And the idea here is also something quite simple. So when I already have Flux that synchronizes all the YAMLs from Git into the cluster, now I will have another application in my cluster, another daemon that would look for a special custom resource. This custom resource is called Helm release, and when it finds those Helm releases, it will make sure that those releases are actually installed using Helm into my cluster. So instead of working with Helm manually, as we probably usually do, I would have this thing also automated. How it would look like. So what we can see here is that here I'm a operator. I put the description of the state into my Git repository. Then I've got this Flux daemon that makes sure that all those objects are created inside the cluster. One type that of those that I define are the Helm release, those custom resources. And then there is this second daemon, so Helm operator, that would constantly make sure that all those Helm releases get actually installed using Helm inside my cluster. And I've got those applications that are defined actually installed. Okay, there is another demo. I don't have enough time to show you this whole demo, but we'll try to show you only some part of it. So only to show you how this concept looks like. So first of all, the two daemons running in the cluster, so Flux and Flux Helm operator. And then the second thing is this custom resource. So I would put this custom resource into the cluster. First thing, I still need to define the namespace that the application will run in. And the second thing is the custom resource itself. So it is quite a simple definition. It says that it's kind Helm release, and that I will be installing the chart defined inside my Git repository from branch master and from directory charts demo. So if we look inside this directory, I've got the standard Helm chart defined here. Okay, so I think I will go only 2 steps further to show you how it starts to work. So again, we are looking into what's inside the cluster. And now I'm committing these changes to Git, push it to GitHub, and see what's happening. Okay, so changes got pushed. Those are logs from this Flux daemon, and we are waiting again a few seconds before changes got applied. Okay, so now I have only the namespace created and this custom resource Helm release also created. And here is also this Helm Flux operator running in the cluster, and it has handled for us the other part. So basically it cloned the charts and then created the Helm release. Okay, and the last step, let's see what Helm will tell us about what's running in this cluster. So we've got this demo release just installed. And the other one is the Flux itself, because it's also installed as a Helm release. Okay, if you are interested in this, you can also try yourself running the other examples, but those are just simple things like changing the configuration a little bit. Okay, so back to the presentation. I think, yeah, so I would now only wrap it up all together. So there are the 3 tools that I've shown you, and there is the GitOps idea, the concept itself. So the concept is like agnostic about what tools you really use, and it is basically to with those goals in mind. So you describe declaratively the whole system. You use version control to put all the desired state within. Then the changes that got applied to the system, you can think about that those are only the approved changes, so you can use all the familiar workflows working with version control. So you can put any kind of a process on top of it, like you would require some merge requests to be accepted, some review done, stuff like this. So it is those are topics outside of interest of tools like Flux, but it is that those when we put all those in version control, then it is quite easy to achieve those kind of processes. And we've got software agents that are constantly ensuring correctness. So as I've demonstrated, when I, by mistake, deleted things from my cluster, they got automatically recreated. Okay, so those were the topics, the 3 tools that I've tried to show you. I again apologize that I didn't manage to show some of those demos in full length, but I hope you still got the basic idea that I've tried to present. And those are the materials if you are interested in those topics. So there is official site for the Flux CD project, and then some demonstrations. Okay, right. Thank you very much for listening.
How you, in GitOps way, seed everything?
You mean how to bootstrap the thing?
Yes.
Yeah. Actually, I don't use GitOps to bootstrap it, but what I found was that for a freshly installed cluster, I need only 2 steps made outside of GitOps. So to install Helm, and then use Helm to install Flux. And those, currently I use just a bash script with 3 lines of, only something like this. I've also seen people use Terraform for that. So also could be done.
Chicken and egg problem.
The question is what happens when you install something manually. So with Flux doesn't care about what's in the cluster so the things that it didn't install. It doesn't touch those things. So it's achieved by using some special labels. So each object created by Flux got labeled so it knows what to care about.
Do you know any other CI/CD tools other than Flux? That can be used for the GitOps purposes?
There are other tools. I haven't tried those. I've heard quite good things about a tool called Argo CD.
Argo CD.
Yeah,
okay.
But haven't tried. And
Which version of Helm did you use?
It's Helm 2 still.
So what about problem with tiller? Because it's high availability problem because it's only one tiller, one instance of tiller in your cluster. So
I haven't tried to anyhow overcome it, but also haven't looked at it as something like a big problem. Because actually, to me, it's just the configuration management layer. And for example, in the previous time when I worked a lot with Puppet, I also kind of have, for example, only one Puppet DB. So there was single point of failure for configuration management, but it wasn't a problem to me.